Thank you, Brian, Dave, for organizing this session. I'd like to tell you a little bit about the long-term ARS experimental watershed network and its evolution and lessons learned. Well, it's probably not as old as the network in Italy that we saw. It's probably one of the oldest in the United States. Again, talk about some early history and establishment, evolution, some challenges in having gone from an analog to a digital era. Some current multi-location projects, some of the future that Mark talked about in the beginning of the sessions, and then some lessons learned. So in 1935, the Research Division of the Soil Conservation Service, this is post-Dust Bowl or during the Dust Bowl, established 3 small experimental watersheds in Ohio, Texas, and Nebraska. And this became part of the Agricultural Research Service when it was established in the mid-50s. And, you know, opposite today, the Senate went all around the country to conduct hearings about the need for better water resources information as related to agriculture. And that resulted in Senate Document 59, which really identified the hydrology of agricultural watersheds as a high priority. And here's some of the quotes from Senate Document 55 that, you know, really, I guess, very much parallel what networks are trying to do today. A national research objective was established mainly to understand how all types of conservation affect both within watershed and outside of watersheds. You know, a need to have these in regions throughout the country. So again, a neon type design, and then again, the need for a very multidisciplinary approach. 6 centers were established initially with a primary location and with numerous satellite locations. And again, they were set up to measure a common set of variables with standard protocols. So the blue manual that you see in the lower right is basically those common protocols, the Field Manual for Research in Agricultural Hydrology. And that, this is still a very, very good reference. And we have digitized it if anyone wants it. But again, we're going to evaluate the effects and relationships between runoff water yield, precip, cover, conservation practices, etc. So we've established, and most of these got, you know, ramped up by the mid-60s. So since that time, they've been really a good network of stable, high-quality research platforms. They cover a range of hydroclimatic regimes, as we can see, from a losing environment down in Arizona to gaining environments in the Midwest. They typically offer very dense observations in time and space. Our experimental watershed is 150 square kilometers with about 100 rain gauges in it. They're long-term locations, and typically they're in nested locations. So there's about 100 watersheds currently being monitored from 25 hectares to about 600 square kilometers. And really importantly, they provide a very long-term, not just a database, but a knowledge base. And consequently, you know, there's process-based understanding about how these systems work, and that has really served as magnets for collaboration, leading to interdisciplinary field campaigns and things like validation of remotely sensed instrumentation, a variety of other places where people do come in for a short period of time. Most of the watersheds have developed a special section of papers describing their watershed, their data collection, and a number of the major research results coming out of those. And again, we can get you that information if you'd like. Most are privately owned by design. They were meant so that we would have to work with the landowners and their management of the land. And again, that presents some challenges, but also presents some advantages. So in terms of evolution, though, so we started out with this very common goal with very uniform instrumentation. Of course, it was all analog at that time. But then the Clean Water Act came along in 1973. And again, ARS is a mission-driven agency. We're not just doing research for research, but we have to address important problems for society, agriculture, and the environment. So when the Clean Water Act came along, a lot of data collection was expanded within our network, but because of regional agricultural production differences and different issues related to water quality, different things were collected. So while we started out as a uniform network, we started to diverge in terms of starting to address regional issues. So again, this led somewhat to a divergence of the network, and climate change awareness then, recently, I shouldn't say recently, it's in the last 10 or 15 years, we've brought in, carbon flux monitoring, biogeochemistry, and that sort of thing. So, numerous accomplishments here that have come out of the watersheds. I'm not going to list all of these, but the point is, and again, it depends on what you want to address. We've got a national network that's maintained continuity, but it's adapted to changing research needs for regional issues. So, some of these new networks that are coming along, do you want to have that flexibility, or are you going to sort of keep it the way it is when you set it up and designed it in the first place? Again, there's trade-offs to each of these. Some of the challenges, somewhat jealous of the folks that are starting all in the digital world. Just in our watershed, we had 7,000 paper charts a year from our weighing rain gauges as well as runoff instrumentations. When we did go digital, we ran a parallel network of about 100 gauges with digital side by side with analog, just to make sure we knew what the statistical characteristics and differences of those were. And to bring this to really accessible to the internet, Susan Moran did a pretty good job tracking the cost. A lot of this is people, of course, but it was about $700,000 to bring this data set from Walnut Gulch into an internet-ready access. Another thing that maybe, again, from a standardization standpoint, measurements what were seen to be suitable for one part of the country were not suitable for another. So the first runoff flume that was designed for Walnut Gulch was designed from Eastern hydrology standards. They had no idea these desert basins could generate the kind of runoff water, and the first one, it just blew out. I guess luckily it was in the first year or two. So I had to go back to the drawing board. Sediment, for example, most pump sediment samplers were a much more bedload dominated sediment transport system. Pump samplers just don't give a very good representation, so by trial and error, our folks, very handy folks, developed a traversing slot sediment sampler that samples the whole cross section. So, I had talked with some of the Neon folks too about, some of these very similar issues, and I'm concerned because we see it in our case where, some of their sampling stuff's got to be right in the channel. Well, I hope it stays there after the first big event. And they said, well, we really can't divert it into another location because that doesn't work with our design concept. And again, nothing wrong with that, but there is going to be some trial and error on any of these systems. So I guess put some budget in for that sort of thing. So, number of multi-location projects are underway, and again, I'm not going to go over all of these, but we do still, even though there's been somewhat of a divergence in the network, there's still a lot of commonality, and in many cases we've got 50 to 70 years of data, and those are going into this list under our current 5-year research plan. So these were set up and developed really before LT-AR formally has come into our research undertaking process. So Mark talked more about LT-AR. Again, vision and goal statements are put in here. And again, we're building on much of the infrastructure that we already have in our experimental ranges and watersheds to get this thing going in a relatively short amount of time. And again, you saw those flumes, those huge flumes. I don't think we could even build those these days with dredging restrictions and that sort of thing. So we've got some great infrastructure, and we want to build on it and utilize it. So another thing that we really see as a potential advantage, at least within ARS in LT-AR, and it's not just ARS, but ARS, there's sort of the plant folks, the animal folks, the food safety folks, and the soil and water folks. And often we've sort of worked apart in different places or scales. So when a new cultivar or animal breed comes along, they may, they're going to collect some data, just like we collect data on, what's the yield of these things, what erosion might be caused, but, they're often doing trials at a field scale. And our hope is that a lot of these field scale trials for new plants or animal varieties can be done within the LTAR network, so that landscape scale measurements can be coupled with the field scale measurements. So again, how do we effectively combine these approaches to assess the integrated effects and also, of course, look at production and economics? In addition, to look at ecosystem services, what's beneficial, what may not be in terms of moving forward. So some lessons learned. Instrumentation may not be universally suitable over diverse environments. And again, as I say, trial and error, I think, is going to be inevitable. I know that the Neon folks are very smart people, and I wish them all of the best, but stuff happens. And, okay, time and expense for permitting and access is considerable. You can't ignore that when you look at a lot of the issues. Personnel with the good technical field and fabrication skills are in short supply. I don't know what you folks have found who are in these other networks, but this isn't the typical skill set you get in sort of an undergraduate hydrology or eco-hydrology education. So a lot of our folks will have to learn on the job. Now, a centralized funding model may help ensure network uniformity. So this is a little bit different about our networks. Our monies come to the locations versus being held centrally, so that there's potentially different leverage, if you will, on saying, well, you shape up your network and get it into these standards, or you don't get your money. So not having a central network, again, enables independence, but will everyone stay on the same wavelength going forward? Sciences and societal changes will emerge that we didn't anticipate. And can you maintain your interoperable network for the long term, but yet be flexible enough to meet what may be unanticipated or unknown societal changes? So again, a few lessons learned. Hopefully they'll be of use going forward to some of you folks, but it's been a good ride. Thank you.